learn today is the Intro to Kinetics for AP Chemistry. Kinetics is the study of how fast a reaction happens. So a lot of our conversations this unit will be talking about the rate of a reaction. So for a reaction to occur, two things must be met. The first is the two molecules must collide with enough energy. If you think about it, imagine two cars that collide very, very slightly, nothing's going to happen. But if they collide a lot faster, then there's going to be a crash. So it's the same thing with molecules. They must collide with enough energy for the reaction to happen. So that is called activation energy. That's the minimum threshold of energy needed for the reaction to happen. The second thing is these arrows I drew are not super accurate. The reaction needs to happen at the proper orientation. In other words, maybe this exact part of the molecule needs to hit this exact part of the molecule for the reaction to happen. And so the second condition for the reaction to happen is called orientation. So it needs to hit with enough energy, it needs to have at least the activation energy, and it needs to hit with proper orientation. Now let's consider these cases on the left and what will happen to the rate. If the states of matter of the reactants are all the same, homogeneous, then the rate is going to be faster. Imagine you have everything in the same aqueous environment. It's going to be a lot easier for those molecules to react and for the reaction to happen. And so vice versa, if the reactant states of matter are different or heterogeneous, the rate is a bit slower. If the concentration of the reactant is decreased, what will happen? The rate is going to go down. That's because if the concentration is decreased, you're going to have less stuff. So there's going to be less collisions in general. Imagine the concentration was way higher. There's all of these. There's going to be way more collisions, and the reaction is going to be faster. So when the concentration is decreased, the rate goes down. Imagine the temperature is increased. If the temperature is increased, the molecules will have more energy, so they'll collide faster and harder, and more of them will meet the activation energy. So the rate will increase if the temperature is increased. Catalyst we'll talk about in a future video. Basically lowers the activation energy, so it'll increase. We'll talk about that later in another video. When we look to the right, this is a question the AP test could ask as an MCQ. It could say, what's the average rate of change of Br2 from like 0 to 100 or 200 seconds? Or let's do 100 seconds. All this is going to be is a basic slope calculation where these are 2 points. So if you calculate the slope between these points, we'll do this minus this over 100 minus 0. And when I put that into my calculator, I get 0.0. About negative 3.54 times 10 to the negative 5. Note the negative sign. We're going to talk about that in a sec. So another thing that could get asked, and this is a very common question, is they'll give you a reaction like this with balanced coefficients. If we look at the same table but for Ki is going to be getting used up way faster because every time the reaction happens, one Br2 molecule gets used, but two Ki's get used up. So the Ki is going to get used up quicker. The concentration is going to use quicker because two of them react every time the reaction happens. So it's not really an accurate way to gauge the rate. So what we do is we're going to do the same thing as we did above, where we did delta Ki over delta T. However, because two of these react every time, we're going to divide it by 2, just like this. And note how I said the negative sign earlier. That's because in reactants, the concentration is going to go down because they're getting used up. On the products, however, it's going to have a positive sign because their concentration is going up. They're being formed. Their concentration is increasing. So a problem they could ask is, so for clarity, this one right here would be delta KBr over delta T. Again, divided by 2 because that's its coefficient, and with a positive sign because it's a product getting formed. So they could also ask and be like, the rate of formation of KBr is like 0.04 like molarity per second. What is the rate for Br2? So first we know that KBr, this you have to divide it by 2 because there's a coefficient of 2. And divide this by 2, you'll get 0.02. And then Br2 is a reactant, so it's going to need that negative sign because it's getting used up. M per S. Okay, so what we calculated is the average change in concentration. If you look at a graph, you could also see the instantaneous rate. It's then calculates the rate at this exact moment. So why is this important? This is important because they could give a table like this, and this will flow nicely into our next video. If we look into points like 50 and 250, notice the concentration of Br2 halved. It went from 0.01 to 0.005, and the rate also halved. That tells me that they're proportional. In math, when something is proportional, we can write it as y equals kx. Here it's no different. We're going to write rate equals k times our concentration Br2. So this is the case when it's proportional to Br2 to the power of 1. In our next video, we'll talk about what if it's proportional to Br2 squared or to the power of 0. So today we talked about the two thresholds that must get met for a reaction to happen. It must meet the activation energy, and it must collide with the proper orientation. And some factors that affect the rate, all here. And calculating the average when given a reaction. Thank you, and that's our intro to kinetics today.